Hi everyone, my name is Jay, and today we're going to be talking about atoms. So, atoms are the focal point of chemistry, and chemistry is defined as a science that deals with the composition, structure, and properties of substances and with the transformations that they undergo. So, people who work with chemistry work very closely with atoms because atoms are what make things happen and they compose everything. From the screen that you're watching this on to the tips of your fingers, atoms make up the world you see around you. So, by the end of this video, you should know the basic subatomic particles of the atom, the basic structure of the atom, and how to interpret the periodic table. So, let's go ahead and start with some vocabulary. Let's start with a neutron. A neutron is a subatomic particle with a similar mass of a proton that does not have an electric charge. So the way that you can remember that a neutron does not have an electric charge is because it's neutral. That's how I remember it. Next is the proton. The proton is a subatomic particle with a similar mass of a neutron with a positive charge and equal magnitude to electrons. So, some takeaways. It has a similar mass to a neutron, and it has a positive charge and equal magnitude to electrons. Those are the key points of a proton. The way that I remember the proton has a positive charge is because proton starts with P and positive starts with P. Next is the electron, which is a subatomic particle with a very small mass and a negative charge and equal magnitude to protons. So the takeaways from the electron is its very small mass and its negative charge and equal magnitude to protons. And the way that I remember electrons is because they're not part of the nucleus, which we're going over next. The nucleus is a small, dense region that consists of protons and neutrons at the center of an atom. If you know things about cell biology, you'll remember the nucleus as the brain of the cell, where the cell gets its instructions from. In chemistry, the nucleus is the center of the cell. It's what the electrons orbit. The electron cloud is where an electron might be found surrounding an atom's nucleus. Now, you're probably used to seeing atoms with some sort of haze around them instead of individual dots. That haze is in reference to the electron cloud because atoms move around so quickly that we can't really identify where they might be at any given time. So we know that they're somewhere within the cloud, but we're not really sure where. So, an important takeaway is that for every proton, there's one electron and one neutron. So here I've drawn a very basic structure of a carbon atom. It has 6 red dots, 6 blue dots, and 6 green dots. Because you want your overall atom to remain neutral. So you have to have an equal number of protons and neutrons because that's what constitutes the nucleus. And you have to have an equal number of electrons and protons because an atom that is positive is not happy and an atom that is negative is not happy. So you want to keep it as neutral as possible. Carbon has an atomic number of 6, meaning it has 6 protons. 6 protons means 6 neutrons and 6 electrons. Just remember again that in comparison, the proton is very, very big compared to the electron. The electron is very, very tiny. Think of this as comparison with a rock to a grain of sand. The grain of sand doesn't really look like a lot when you compare it to a rock. The same way electrons don't look like a lot when compared to protons. So the way that you're going to be seeing atoms and the elements that they make up in a periodic table is going to be like this. The top number represents the atomic number. That's the number of protons in the nucleus of that atom. So for nitrogen, it has 7 protons. 6 is oxygen. The atomic symbol for nitrogen is N. So you'll start to see shorthand where nitrogen is N, and oxygen is O, and hydrogen is H, things like that. It's a way that we write out chemical formulas further on in chemistry. You'll have the full name of the atom, and you'll have the atomic mass. Now, the atomic mass is typically this number times 2, and that's because you have 7 protons, so you have to have 7 neutrons. And if you remember from the vocabulary, the mass of a proton and the mass of a neutron are very similar. The mass of an electron is so minute that it doesn't really cause a dent in the atomic mass, but it is counted in there. So again, this is going back over what I just said. The atomic number tells us how many protons are in a nucleus. The atomic weight is how much the proton's nucleus and electrons weigh. The weight is mostly made up by neutrons and protons because electrons have such a tiny mass. So this one's for you to solve. I want you to tell me how many protons there are in an oxygen atom, how many neutrons are in an oxygen atom, and how many electrons are in an oxygen atom. Go ahead and pause the video and we can do it together once you're done. Alright, so first things first, the atomic number. The atomic number here is 8. We remember the atomic number represents the number of protons within an atom. So there's going to be 8 protons. In the nucleus of the atom, the number of protons equals the number of neutrons. So if there's 8 protons, there has to be 8 neutrons. And then we need to remember that we keep the cell neutral. So if there's 8 protons, there are also 8 electrons. And that's the basic overview of atoms and an introduction to chemistry.